Hi everyone, my name is Ibrahim. I'm a PhD student at Birkbeck, University of London. Today I will briefly talk about the approach adopted by our team for the DREAM challenge. We used a modified temporal convolutional networks and a custom loss function to predict the expression profiles of random promoter sequences. Our model outperformed two benchmarks, the transformer neural network and the biochemical model, as per the weekly leaderboard results, which only used 13% of the testing sequences. For the pre-processing step, firstly, we performed a character level encoding using a dictionary of 5 characters, transferring the sequence of characters to a sequence of integers. This is done to prepare the sequences for character embedding. The second step was binning. As the training sequences had different lengths, we grouped them into bins where each bin holds sequences of the same length. After that, we discarded the bins that hold less than 1000 sequences. The figure shows the sequences distribution over the selected bins. This slide describes our model. The embeddings are treated as learnable parameters. The residual block is borrowed from the original TCM paper. The number of residual blocks or levels is based on the maximum sequence length to ensure the receptive field covers the maximum length. Our loss function is designed for the competition. Because the output is a real number, we used mean squared error. However, the main matrices were the coefficient of determination and the Spearman correlation coefficient. Hence, we multiplied MSC with a small number, 0.1, so the main two matrices contribute more to the final loss. Due to the highly noisy training sequences, we trained our model on the entire training sequences. We use batch training over the 23 bins, exploiting the ability of TCNs to be trained on variable length inputs. We use the weekly leaderboard results for hyperparameters optimization. The table on this slide shows the used hyperparameters. The figure on this slide shows the training curves with respect to each metric. The model showed stability during training. It also improved both matrices with the increased number of training epochs. The curves show there is still room for improvement. We have reached the end of this talk, and we would like to thank everyone who attended.